OpenAI is deploying GPT 5.4 Mini and Nano today. These are high-volume, low-latency models built to handle massive enterprise workloads without bottlenecking system speed. Until now, development teams faced a rigid constraint. You could route tasks through a massive, highly capable model that was too slow for real-time applications, or you could rely on a smaller, faster model that struggled with complex reasoning and tool use. GPT 5.4 Mini changes that balance. It processes data more than twice as fast as the previous GPT-5 Mini generation, yet its reasoning and coding capabilities sit just behind the primary GPT 5.4 flagship. By cutting processing time in half while maintaining high accuracy, these models allow for real-time interaction in scenarios where latency previously made AI deployment impractical. Looking at the performance data, the most significant gains emerge in automated software engineering and real-time visual navigation. This chart compares accuracy on SWE Bench Pro. SWE Bench Pro is a rigorous dataset that tests an AI system's ability to resolve real-world software issues found on GitHub. Despite requiring a fraction of the processing time, GPT 5.4 Mini scores 54.4%, directly trailing the flagship model's 57.7%. Shifting to OS World Verified, a benchmark measuring how well a model can interpret computer screens and navigate user interfaces in real time, the jump is steeper. GPT 5.4 Mini hits 72.1%. That nearly matches the flagship's 75%, eclipsing the 42% scored by the previous GPT-5 Mini. For tasks where speed is the absolute priority, the new GPT 5.4 Nano model offers an even lighter tier. It is optimized strictly for background automation, like sorting large datasets, classifying text, and extracting key data points. Because these models can accurately interpret dense user interfaces at high speed, integrating real-time visual processing into consumer and enterprise applications is now technically feasible and highly cost-effective. Pushing every user request through a single massive AI is an inefficient way to build software. The new standard for enterprise architecture is sub-agent orchestration. This diagram shows how the Codex platform structures these workloads. A large flagship model like GPT 5.4 acts as the executive planner. It handles the deep reasoning, coordinates the workflow, and makes the final judgments, but it delegates the execution. That central planner hands off parallel, highly specific subtasks, like searching through a massive codebase or reviewing hundreds of supporting files, to a swarm of GPT 5.4 mini subagents. By routing the heavy lifting to smaller models running concurrently, complex coding jobs are completed faster, utilizing only about 1/3 of the standard compute quota. Developers are shifting from monolithic reliance to composed systems. Large models plot the course, and smaller, specialized models execute the steps at scale. GPT 5.4 Mini is available immediately across the API, Codex, and ChatGPT platforms. The ultra-lightweight Nano tier is accessible exclusively through the developer API. The pricing structure reflects this high-volume focus. Nano is priced at 20 cents per million input tokens, while Mini costs 75 cents. Mini also includes a 400K context window. A context window is the total amount of text or data the AI can hold in its active memory during a single prompt. At these price points, running thousands of parallel operations for real-time ranking or continuous data extraction is economically viable at massive scale. Engineering teams should evaluate their existing AI pipelines. Routing simple, high-frequency tasks away from flagship models and into these targeted sub-agents will immediately cut latency and reduce operational overhead.